One of the biggest challenges to widespread adoption of renewable energy sources is long-term energy storage. And Curtis, at Hydrostor, you've created a solution that uses water and gravity to have a zero emission source for long-term energy storage. How does your solution work?
We adopt techniques, construction techniques and equipment from oil and gas industry. And what we do is we sink a shaft about 600 meters down, hollow out some space in rock, flood it with water. We then use natural gas equipment to compress air, send it down and lift water up, hold it in. And when the grid needs power, you open the valve, the weight of that water brings the air up, it spins a turbine and air goes back to the atmosphere. And you have low cost, long duration energy storage that can be built anywhere there's rock.
And the cost to dig, it sounds like a big project to dig a big hole. You had the mining shaft example where you're able to reuse some legacy infrastructure from mining. How much does that save costs, and what do you have to do if you have to build a fresh hole?
What we tend to do is we compete with natural gas and coal plants, and at that scale it is very cost effective. But to prove it out initially, we started with smaller projects. It would not be cost effective there, so we looked for pre-existing holes in the ground that we could repurpose, and so we've built a couple of those to prove it works, and now we're focused on the much bigger projects where the grid needs them.
What is the cost comparison between the traditional ways of storing energy and yours?
As there's more renewables on the grid, you need more storage and you need longer duration storage. So batteries work really good for 15 minutes or shift an hour here and at the residential level. But when you go to the grid and you start moving major blocks of power from day to night, batteries are just not cost effective. To give you a sense, adding 1 hour of duration per kilowatt hour of a battery is about $300. Adding 1 hour of ours is about $20. And so much more cost effective. In line with that of pumped hydro, the issue with pumped hydro is it can only go where there's a dam. What we do is we bring that cost profile anywhere you could build batteries really. And so now we bring the best of the flexibly sited batteries with the low cost of pumped hydro.
What do you think you'll do when these types of projects are widely deployed in Hydrostores and many, many more places? Will you be able to replace a lot of the battery infrastructure that will be deployed, or is this going to exist in tandem with batteries?
Yeah, you really need batteries. They can respond in milliseconds. They can tuck into someone's garage where they need it on the end of a feeder. We're not going to make sense in those applications, but what we see is replacing every coal and gas plant on the planet. If batteries and other things haven't done it, we have the flexibly sited and cost to go in and take out those plants.
There's been a lot of investment in infrastructure in coal and oil and gas plants. CapEx generally, and capital expenditures generally, are a challenge for utilities. So how do you model that where you're able to get enough availability of capital to actually make your solutions work?
What we found is the capital to build isn't the issue, it's getting the contract. And as utilities are adding more renewable to the grid and they realize their transmission lines are in the wrong spot, they're getting more creative in giving more contracts. Once we have that contract, the supply chains we use are oil and gas. They exist and can build hundreds of these all at once. And the capital seems available from the capital markets if you have the right contract and what we call a bankable solution that people know will work.